You need to switch over to PowerPoint. And Alice might be up there.
Very good.
Okay. Good evening, everyone. Welcome to Sperry Observatory, where we make with Amateur Astronomers Incorporated makes its home here at the observatory. Tonight, our speaker is Al Witzko. He is a longtime member of AAI. He is a past president. He's currently our recording secretary, and he has had a very interesting career. He's known as an optician, and he's been a longtime member of AAI. So with that, Al, please.
Okay. Thank you. I'm wired up, as you can see. Can everybody hear me?
Yes.
Okay, great. Okay, well, first of all, good evening. Welcome. We're going to be talking about a phenomenon that's coming up actually in a couple of days. The January 2025 opposition or closest approach of Mars to Earth, and some of the latest news about the red planet. So I'm going to do that. Since apparently everybody can hear me, and I hope on the web too.
Can you increase the volume now?
Okay.
But we cannot see the PowerPoint anymore. Please put it back.
That's fine. Okay, is that a little better?
Bonnie, please put the PowerPoint back.
Hold on, I'm on it. You can start out.
Okay. Are we, yeah, I guess you can hear me. I can hear a little echo there. Terrific. Okay, we're going to be talking again about the red planet. And also after the talk, and we'll do question and answers, we're also going to do something else. One of my hobbies within the hobby, if you will, in astronomy, is collecting meteorites, stones from space. Most of them obviously from the asteroid belt, but occasionally we get a very few from the moon and from Mars. And I've got one of each over here today. We had to do a lot of horse trading and a lot of trading of materials to be able to get them, but that way everyone can get up close and personal to two other worlds in our solar system other than what we're standing on. All right, can we go back? We shot past. No, I guess that's it. Okay. All right, there we go. So here we are talking about Mars. Surface gravity is about 38% of here. It's similar to Mercury because Mars is of a lower density. Or to put it another way, if you weigh 100 pounds on Earth, up there you only weigh about 38 pounds, which is terrific. The crust of the planet itself is very thick, supports huge volcanoes, but the average daytime temperature, and this is in the summer, on average, is about minus 25 Fahrenheit. So it's a rather cold planet out there. No real general magnetic field. I had one once because Mars meteorites, like this one over here, show some magnetism. There is indeed a solid core. Martian meteorites are as young, if you will, as 180 million Earth years old. They contain basalt like we have out here in the Watchones and in the Palisades, and volcanic minerals. Next. Okay, just to give an idea of comparison, this is Earth, of course, lucky us. That's Mars, and if you notice on it, you're seeing also water vapor clouds, especially around very high mountains, such as these three and another one. These are all volcanoes. There's another one over here, a patch over here, which had no explanation until very recently when I talked about that too. Okay. Next, please. Okay, this gives a general idea of elevations. If I didn't know any better, I swear that if there was water on the planet, it's blue only because it's color coded. It's as far as 8,000 meters. That's about 24,000 feet below the highest, or the 0 point here, rather. So you could have had an ocean up there. But there's a lot of interesting stuff, such as these three volcanoes, a big, as in the size of the United States, canyon that stretches across the red planet, and two big impacts from objects here, because Mars is near the asteroid belt. I have no doubt that something rather large twice hit the red planet quite some time in the past. Next. Okay, and it has two moons. We have one, of course. Here we have two. They're named Phobos which is the one closest to me here, in Deimos, on the back, from the Greek for the two sons of Ares, fear and terror. Now, they may be captured asteroids, or at least in the case of Phobos, there's a theory that a big impact happened here. Big crater ripped something out from it, and that's where Phobos came from. Okay, there are possible plans to stage for a landing, places to stage for a landing on the planet in the future. Good to have a base up here of operations, and then you have normal surface operations at the same time. Next. Okay, there's an area of it on the western edge called Tharsis, and as I mentioned several times now, you have 3 volcanoes and one large one. This is Olympus Mons. This whole area is bulged out. It's 2,500 miles across and 6 miles high. And the various names and such are derived from Greek mythology and such. We did not expect that big volcano, I'll tell you that much. That is big enough that if you made a big plaster mold of it and brought it to the U.S., to Hawaii, drained all the water, that mold of that big volcano would cover the entire island chain, all the way down to the bottom of the ocean. So it's big as things go. Next, please. Okay. We've seen with our spacecraft dune fields, wind streaks that you see to the bottom there, and there are dust storms that completely cover the entire disk of the planet. Okay. Yeah. Okay, now the winter conditions, you think it's cold today, you ain't lived until you've been on Mars, because the temperature of the ice cap here is roughly 200 below. It's dead of winter. And it's not just water ice, it's also frozen carbon dioxide. So it's dry ice. And this seasonally disappears, goes back and forth on the north and the south pole of the red planet. It's divided between water and carbon dioxide, and the winter polar caps expand and contract. We can actually see that from Earth. They're very bright compared to the rest of the planet. Next. And maybe liquid water in the past. Now, right now, the atmospheric pressure is so thin up there that you can't have liquid water for any long period of time. But sometime in the past, it must have, because these are all cut, these channels are all cut by nothing else than water. Lava doesn't form this kind of sharpness, so it's only water. Where the water went, that's a big mystery. Next, please. Okay, past oceans on Mars? Yeah, definitely. Maybe about 3.5 to 4 billion years ago, this is what it probably looked like. Notice there's a big canyon over here, a big rift, and we'll talk about that a little bit later. But apparently it shows a lot of evidence for a liquid ocean, but unlike ours, it has salt. We have salt in our oceans, but our oceans are alkaline. Here it's an acid. We're not quite sure why that happened. Next. Okay. Curiosity on Mars. This is a spacecraft, a robot. It's still moving about on there. It's nuclear powered. You can see one of the power packs at the bottom. And the photographs taken by this are amazing. It's, I believe it's in its 8th year of exploration, maybe even longer. Curiosity also photographed Mount Sharp in the distance over here. These are actually photos. These are not paintings or drawings. Now, here's a question for the audience. Okay, one of these two pictures, one of them is Mars, one of them is Earth. How many people think that this is Mars? Just from the appearance. Okay, a couple hesitant hands. How many think it's Earth? More. How about this one over here? Is that Mars? How about Earth? Okay, here's the big reveal. That is Earth. This is by a riverbed in Arkansas. This is from Mars. They look very, very similar, and I deliberately make them black and white so it wouldn't give it away. This is usually a bit of an orange tinge, as you can see here. Sneaky, ain't I? But this gives evidence here. We know there's water on Earth, obviously. It's all over the place. And it erodes rocks in rivers and such, and has the same effect here. Next. Okay, this is perseverance and ingenuity. This is an amazing thing to me. I would never have thought, when I was about as young as some of the young people here today, that I would be looking at a robot that not only could rove the surface and analyze the surface of Mars, but had a helicopter as a scout. Ingenuity over here flew about 70 times And finally, unfortunately, when it came down, once it came down a little hard, maybe it hit a little turbulence, even in the thin atmosphere, and it broke the one set of the two sets of propellers. So they didn't want to experiment and maybe ruin it, but they left it there in place. But this was a proof of concept. Could you have a rover that would be following along a scout ahead of itself, see something interesting, and then maneuver to where this robot is? So they proved it. They were supposed to only fly like 9 or 10 times. It did 70. Or finally, unfortunately, it had a bit of an accident. Now, as Perseverance has been moving across the surface of Mars, it has been, shall we say, creating a trail of breadcrumbs, because it has drilled into rocks and has left samples on the surface of Mars for a future spacecraft to go out and retrieve them. However, I just recently found out not only did it do this, but it also cached a few samples within the spacecraft itself. So if they can't find these, because they're small, they're only about this big, about that big in diameter, easy to lose. If they can't find these, they just have to find Perseverance, which is about the length, a little more than the length of this table, and about almost the same height. And then the cameras and such are taller than I am. So this would be easier to find. So they will have samples there. Next. Okay. We wanted to find out more about the interior. So back in 2018, the interior of Mars, we wanted to find out if maybe it's geologically active, in other words, volcanoes and Marsquakes. And sure enough, we put down a Marsquake seismograph, as it's called, on a cable. Next. And we got enough inside details, thanks to that earthquake detector, the seismograph, and a couple Marsquakes that the planet was kind enough to do for us. We have an idea of what the interior of Mars is like. Still warm, not very hot, but a warm core, and kind of cold around the edges out here. So it's similar to Earth and yet quite alien, because our crust here is only about 10 miles thick. There, in some places, as much as 30. And the core is still hot, warm, but ours is still raging away at over 11,000 degrees Fahrenheit. Here, we're guessing if it's 5,000, it's a lot. Next one. Okay, and it's getting a little crowded up there. The Chinese space program sent in 2021 this Zhurong lander, and it came by and it followed to see its backplate as well as its parachute up here. So I wish them luck. Anybody that can land something on the red planet and have it survive and be able to move about and analyze it is okay in my book. Next. But the whole thing here is, why is it so hard to land a spacecraft on Mars and then even operate it? And why is it so hard even to observe the red planet? Two major questions. Young people want to sit down. We do have some chairs around here.
No, there's so much here.
Oh, they're all done? There's
Yeah,
one
you're
over
wrong.
there. Okay. Well, there we are. Okay. So again, why so even hard to observe the red planet? Next. Okay, here it is, that nasty atmosphere. We have a very thick atmosphere on our planet. Oxygen, lucky us, over 20%, almost 21%. Nitrogen, most of it. And then all these other gases and such. On Mars, however, there's a good deal of argon compared to us. Nitrogen's about not even 1.9%. Carbon dioxide mostly 96%. And there are other gases and such over here too. But it's very, very thin. If you were foolish enough to take your helmet off from your Mars roving suit, you wouldn't last very long. You can't breathe the atmosphere anyway because there's virtually no oxygen in its atmosphere. It's a trace element down here. And very cold. The average cold temperature is roughly about minus 25 on average in Fahrenheit. Mars' atmosphere is about 100th that of Earth. But if you have a spacecraft going at about 19,000 miles an hour, that is an almost impenetrable barrier. So you have to have a heat shield, which adds weight and expense. And you also have to hope that the computer's going to work properly, too. Next. And anybody notice this is a sunset? Anybody notice something interesting about this? Got a hand here.
there's you don't see the strips, the colors of the sunset. When while on Earth here, you would see the
That's
different
exactly right.
colors.
Yeah. We have a reddened atmosphere because we're looking through almost 100 miles of atmosphere. So as the sun goes down, it goes from a nice bright white to a yellow to an orange to red. In this case, though, the atmosphere is just dense enough to give you a blue sky and a blue sun. So that's a very strange sunset, but it's Mars. Next, please. Okay. And there's other evidence here too of things. This is a volcano, very large one here, somewhere in the order of 11,000 feet high. And apparently it is enough to interfere with the movement of air, which has a little water vapor in it and gives this trail much closer to what we see, these fine cirrus clouds that we see in the winter here. This is almost like a very, very light snow, but it's not reaching the ground from that altitude. Next. It's way too thin to breathe, and nothing really to breathe in. You can see on Mars, from 0 to 100%, the nitrogen is barely 2%, oxygen only about 2%, argon is about the same, an exotic gas. But look at this carbon dioxide, as much as 75–80% of the atmosphere. Here, lucky us, we have nitrogen, which keeps our plants and such growing. We have about 21% of oxygen, 1% of argon, and about 1/4% thereabout of carbon dioxide. So we are very lucky. We live here. We don't have to go running around in spacesuits when we leave the building. Next, please. Okay, so what would it look like if you were standing there? And these are 3 photographs. One that's been unprocessed as color and uncalibrated. This is raw data right down from the spacecraft. This is natural color, which uses calibrated data. In other words, it's got a set of colors that the camera can look at, and then we can interpret the colors here. The white balance assumes here that there is something in here that's white, and there are very few of them here. The actual view, I believe, is this one. This has been processed a little too much, and yet this one over here is just the raw data. So I believe this is as close as you're going to get to how Mars actually looks if you stood there. Next, please. Okay. Now, coming up on another couple days, Mars will reach what we call opposition on January 16th, 2025 at 9:32 p.m. Eastern Standard, located high in the east around that time in the constellation of Gemini. It'll be fully illuminated from the sun as we see here from Earth, and it's going to be visible all night. Its diameter is about 14.5 arc seconds. That essentially means it's about, well, that's the hard part because we can show you Jupiter tonight. But consider it going to be very small. You need a telescope to be able to properly see it. But its brightness, minus 1.45, that's pretty good. You can't miss it. This orange-red thing out in the east on that day, and for many other days, nights after. It'll be at a distance, though, of 59.7 million miles from Earth. It's not the best viewing conditions, but with a telescope like the 10-inch over here, and if you get a really stable atmosphere with the 24-inch, and of course there are tricks you can do too, where we can photograph it, a number of pictures, feed it into a computer and come up with an image. I like doing both, being able to process the image, but also just look at it and see if I can challenge my eye, and anyone else's for that matter, to be able to see detail that only is there fleetingly because you got this wonderful atmosphere we have.
First, get rid of the clouds.
I'm sorry. Oh, well, the clouds, I mean, they come with the hazard. What can I say? Okay, next. Okay. So there are, if you're familiar a little bit, and I hope not really believing in it, in astrology, we borrowed a lot of their terms for positions and put it into astronomy and then ditched all the rest of it. When the Earth and Mars are usually closest at a given time, it's called opposition. It is opposite the sun as seen from Earth. It's a good time to observe the planet. Conjunction, on the other hand, is when the planet's on the far side of the sun. Usually we can't see it, obviously, from Earth, because the sun's blinding us. But this is what opposition means. And you can, because well, we'll get to the next slide then. It's easier to go that way. Okay, well, this is what the effect occurs. Right about now, we're very close to maximum size. Starting in November, starting in November was about the beginnings of the diameter of the planet being big enough to do serious work, though I know people that can't wait and they will use computers to process their stuff, their equipment, imagery, and then be able to get some pretty good photos. On the 16th, this is about as big as it would get relative to the rest of the dates. When it drops below 10 seconds of arc, as it's called, that's when photography should be stopped and you just go to visual, because the human eye can still beat a camera, whether it's digital or film. But then it goes, in May, it's going to start getting too close to the sun anyway to view. So it gives a rough idea. If this was a couple oppositions back, Mars was about double the size, almost 25 arc seconds across, a very close approach. This one, it's not the best in the world, but if you got decent eyes, you just stare at it for a little bit. Every so often the atmosphere stabilizes out and you see good detail. Next, please. Okay, and I mentioned before about oppositions. This is between 2012 and 2027. This is ours right now. You can see we're rather far away in this case, and it doesn't get too much better for a couple of years. In the early 2030s, though, it's going to be very close again, like it was back in 2018. So it was relatively large, and that's because our orbits are slightly elliptical and Mars is much further out. You can see we're almost perfectly circular. Mars is a little offset. So it makes it an intriguing thing to look at. Sometimes a little maddening too, because you want to see the detail and you got to allow for the fact that the planet also rotates on its axis once every 24 hours, 30 some odd minutes. So the feature you see tonight is going to be a little offset. And sometimes you have to wait about a solid 2 weeks for that same detail to come out on the other side of the planet as you're viewing it. Next. And how to view. Say it like it is. The larger the telescope, the better the view, but depends on what we call local seeing. Everyone's familiar with the old Twinkle, Twinkle, Little Star. That is called, formal name is scintillation. It means that the star's image is being, well, quite frankly, being messed around by the atmosphere. It isn't a straight path. The atmosphere will bend the light a little bit and ruin the view. If you have a really stable night, cold too, I might add, during the winter, you can use at least a 6-inch telescope, or you can come down here, because it'll be next week, it'll be after opposition, and we still have a lot of time to view it. When we put in the 10-inch, even the 24, you'll be able to get a decent view of it. But I recommend with your own equipment, get a 6-inch aperture telescope, a red, number 25 red or a number 30 magenta filter, which improves the contrast. This is the red planet. The dark markings are enhanced by a red filter. This number 30 magenta is very recent, about maybe the last, I'd say about 30, 35 years. All this time we're using red filters. Magenta gives you red and blue at the same time and suppresses the green. Now, there's almost no green on Mars, but this brings out contrast. And you also, at the same time, besides seeing features on the red planet, you're also seeing the atmosphere, because that blue light allows the clouds to come through. So it's a much better one. But don't tell anybody that does astrophotography in here doing planetary, because I'm going to have more competition. I know what to do with. So anyway, and you essentially, with any kind of viewing, try to get away from the city lights and into a safe, dark sky site, and dress warmly. There's nothing worse than being at the eyepiece of the telescope, particularly during the winter, and you're trying to look through the telescope and you're being stressed by the cold, you're shivering a little bit, and that it makes it what should be a terrific view, makes it into a nightmare for a while. So I gotta admit, some of my best viewing has been done during the late summer, early fall, back in 1971, way back when. I had just built a 10-inch reflector telescope, and everything on the news we were talking about the Mariner 9 flight or orbit of Mars with that spacecraft. So I go out with the telescope, and it's one of those nights where everything came together. The seeing, twinkling of stars had stopped. There's a little bit of haze in the atmosphere, not much. I was operating at roughly about 200, 250, if I remember correctly, with a 10-inch reflector I built with my own hands. And everything came together. seeing twinkling of stars died down. The temperature wasn't too hot or too cold. Remember, this we were talking here is August. Filters came together, and for the one and only time, ladies and gentlemen, boys and girls, I can convincingly state that I did see the canals of Mars. Those canals, however, are not the straight lines with the train stations in each place and everything. This case, it turned out it was Valles Marineris. Just saw it, and I reached for my notebook. I'm saying, "Oh my gosh, they just mapped this darn thing." I reached my notebook, and I forgot I was on a ladder 7 feet in the air. I crash landed. If you think that you think Meteor Crater felt bad, I'll tell you. I lay there for about 5 minutes and finally turned over to meet my faithful dog Snoopy, Beagle, and he said, "Oh, good, you want to play?" And then he realized there's something wrong here, and dog lands on my back, and he's trying to get me going. I said, "Dog, get out of here." Crawled into the house. I still get twinges from that. I almost cracked a vertebra, but it was worth it. Especially because the drawings came out well. I was able to, this group called the Association of Lunar and Planetary Observers have been doing this work since the late 40s. And my drawing and about 5 others confirmed that Valles Marineris was definitely seen that night, particularly around that time. So I paid for it, but it was worth the cost. And I recommend everyone else not fall off a ladder, but get as good a view as you can of the red planet. For that matter, in astronomy, when we have planets here, please do. Please come down here on Fridays. Maybe if we have a special night for it, we can have the telescopes open. So, okay, next. So this shows the path of Mars in the night sky currently. And what's going to happen is it comes in this way, hits opposition in January, coming up the 12th, actually the 13th by our calendar. It will get smaller and smaller as it goes. It will start to go in what's called retrograde motion. It goes backward because we are passing it now in our orbit in the sun, and then comes out. By the time it reaches maybe, well, I'd say around October thereabouts, it's kind of small. By the time it gets back out of this area and starts going in, it's going to be very tiny. So this is around prime viewing, starting about now and extending maybe into April. So we'll have the telescopes up. By that time, it will, hopefully the weather will cooperate and we'll be able to see it. I can't guarantee anything more, forgive me for saying it this way. For the average person looking in, you might be able to make out the polar caps, maybe even the dark marking on there. The real fine stuff, you need practice to be able to get your eye to look for this very, very small, low contrast imagery. But what I saw that night keeps me dragging me back to the telescope. It's been a wild ride, and still is wild. Next, please. Okay, so let's talk about some current news about Mars. Okay, the MAVEN spacecraft has imaged northern lights, as we call it, aurora, back on May 14th to the 20th last year. These are all indicators that there was auroral activity because of the presence of the sun. And this is a bit of a mystery. There's a very weak magnetic field here. So what the heck is happening over here? Aurora formed because of the fact that we have a magnetic field that captures particles of sunlight, particles of the solar wind, and that enhances the energies in the atoms that allows them to produce colors: green for oxygen, for nitrogen, red for oxygen, and sometimes you get a little bit of a brightening, almost white. And we're having northern lights here now because the sun's active. But in this case, this is Mars. It's not supposed to be a powerful magnetic field, so something's happening here. We're not quite sure what. Next. Okay, running over something is a new discovery method. Tell you, I wonder why people try hitting me on Sunley Avenue in North Bergen. Well, here it is. In Gediz Vallis, Curiosity rover drove over a few rocks, and that's what happened. These are all sulfur. We know that there are those huge volcanoes up there. It probably changed a lot of the atmosphere as well. But this is the very first time we've actually seen this mineral on the red planet. So you're looking at history over here. Next. Okay, and a sample, this surprises me because I collect meteorites. They're a bit expensive here and there, but they're worth having because they use them as a teaching tool. Vesta, or more correctly, 4 Vesta, the 4 refers to it as the 4th asteroid discovered. Gets relatively close to Mars, and apparently some material splayed off it. Maybe an impact hit it. There are craters on Vesta. And then we have this. So this is a large chunk. This would look very nice on my mantle at home. This is about this big. I don't have that type of meteorite, anything bigger than something about like that. Okay? But there are the wide angle shot here has a number of these rocks. This is the largest one. Like I said, anybody can get me this thing, let me know. Okay, next. Okay, Perseverance and samples. Perseverance, like Curiosity before it, is able to drill into rocks. You can even see where it did some drilling over here. But this got very important. Chiava Falls is the nickname for this area, and it appears to show signs of previous life, these little blebs through here. They think might be evidence that microbiological bacteria had at one time lived there, if the theories are correct. It may or may not, and the only way we're going to find out is if we bring them back to Earth, so samples, so that we can analyze it and see. Next, please. Okay, and we've been doing a lot of drilling up there in various areas like Aeolus Mons, Mount Sharp, nickname, Aeolus Palus, and they name them so that you can keep track of which one's which. And you can see some of the material they've taken out. So much of this is bluish gray, some of it's a bit red, white. We're not quite sure what we're seeing over here, but this is the path that Perseverance has been taking in Gale Crater, where it landed. So with a little bit of luck, we might be able to find those pieces that's leaving like breadcrumbs behind it. Something I only found out, believe it or not, only about 2 days ago, that Perseverance is also carrying retrievable specimens from these areas on board. So if we can't find them, say they get covered in a big dust storm. The planet's notorious for having the whole planet go behind a pail of dust and dirt, and we'll hide stuff. Because these are little, they're about this big, each tube, sample tube, about that big. But we've got them inside the vehicle as well. That was new to me, and this is great. Because we may not be able to find a little tube like this. Sure as heck, we're going to be able to see something that's almost 7 feet tall. 7 feet tall, 6 feet by 10. So you should be able to find it, I would think. Okay, next. Okay, and this just in. I've been waiting all night to be able to talk about this. This is amazing. We have a newly discovered giant volcano. We knew of these guys here, Olympus Mons, which apparently is one of the largest volcanoes in the known solar system, Osier Mons, Povanus Mons, and Acraeus Mons. Fine. Something was missing over here. And it would be rather large. Diameter, look at that, 280 miles. Elevation of roughly about as high as Everest, 29,600 feet. They think it was active into modern times, meaning if you had a telescope maybe in 550 AD, and you looked at the right time, you might have seen a massive explosion that blew this thing apart. And made of ashes, lava, and ice. It's very deeply eroded, as you can see. Next. And I need a bit of a close-up over here. Between Noctis Labyrinthus, this is great. Think about that. The Puzzle of the Night and Valles Marineris, Mariner Valley. We've got this. And they're even already giving a name for a place that they would like to land a spacecraft to explore this, what's left of this volcano. Noctis Landing. So this is going to be a stay tuned thing. In the next 10, 20 years, we're going to find out more about this. And maybe, just maybe, they'll get the funding so they can land at that area and then move through. So it was another volcano that exploded, maybe as recently as 2,000 years ago. Okay, and a closer look at it. We believe we're looking at buried glacier ice. Ice is very critical because if you're getting thirsty, this is where you're going to find the water. Follow the water, as they say. There are pyroclast lava and volcanic dust deposits all through it. We think we're looking in some places here at sulfate salts. There may be ice below it. Maybe it's been preserved. And then these are blistered terrain or rootless cones. This might be places where there's steam vents at one time, and there may be water ice there now. As I say, stay tuned. Next. Okay, planning for the future. This is, again, several proposals. I understand that we're having problems trying to get funding for it. Another vehicle similar to Perseverance or the machine itself, maybe an upgraded one with a flying, flying for a longer time, helicopter, if you will, to a lander, this robot will retrieve it. It'll go on board here where it'll launch up to a waiting spacecraft, which then heads out to Earth. And it's a great robot. They're terrific geologists and such. Nothing beats having a specimen in a full-scale laboratory right here on Earth. And who knows, maybe we'll find that there was at one time life there. Maybe there still is. How it survived? Your guess is better than mine. But this is part of the exploration. The young people here, anybody who's under the age of maybe 14 right now? Okay. You guys and girls are going to be able to see whether or not, I think, when you're in your adulthood, when you're maybe, believe it or not, years from now, maybe you're about 25, 30, we might finally solve the mystery if there was life here. You'll all be privy to that. You all will have that. This is my generation's gift to you, knowing what something is or not. Besides love, knowledge is the greatest thing.
We're having human footprints on Mars. Even better.
Yeah, as long as they're mine. Yeah, yes, sure. Yeah, okay, I'm egotistic. I want to be the one, that may have been a small, according to someone else, that might have been a giant leap, small step from Neil, but it was a big one for me. Gene Cernan talking about that. For me is coming to the planet of war and peace. Next. Okay, so the story so far, this place has more spacecraft landed on it because our curiosity is that great. Even the Chinese came in. Tianwen-1, Utopia Planitia, I wish them luck, they're going to need it. Curiosity, Spirit Lander, Insight, Phoenix Lander, that actually discovered some ice, as a matter of fact, underneath the surface where it landed. Perseverance, which is still operational near the Zero crater. Vikings 1 and 2, looking for life and may or may not have found it. And Pathfinder Sojourner, an opportunity in spirit and curiosity, of course. And there'll be more that are going to be going up there. Okay, next. Okay, in the future. Okay, Hollywood's idea of Mars, 1964. I don't know if anybody's ever saw this thing. I think it was the last one they made with a bit of science fiction sort of introduced into it. Especially when it's Robinson Crusoe on Mars, 1964. And until a Friday shows up, it's pretty scientifically accurate. And of course, there are aliens that are firing at them every so often. The basic tenet of it, though, was a survival story. And it's actually a pretty good movie, halfway decent. This is actor Paul Manti looking into a mountain pass. I deliberately cut this off because over here is supposed to be fire from a volcano, and there ain't no operational volcanoes up there, so I just cut it off. I love the suit, too. It's very, very lightweight. We got to find out what that's made out of. Okay, next. Okay, Mars Base 1964 concept. And all right, I'll be honest about it. People who are really, really, really into the history of space exploration, and particularly with NASA, probably recognize this picture because all I did was redden the surface. This is supposed to be a base on the moon. But I say, hey, it's close enough for government work. So I made it redder. This would probably be more realistic for a Mars colony, if you will, underground for the time being. Maybe Mars, the reality, maybe? Mars in 2044, our national is controlling another Ingenuity class flyer to go up a rather dangerous looking cliff face, looking for materials, life, fossil history. Next. Maybe Mars Ops in 2050, like I said, some more young people over here hopefully put their footprints on the red planet, as well as on the moon, maybe elsewhere. And I like to fantasize that's me after I've been cloned inside here, so I'm a bit younger. Any way to look at it, it is incredible. and hopefully maybe reality soon enough. Next. So in conclusion, imagination is as vital to any advance in science as learning and precision are essential for starting points. That's Percival Lowell, short about 10 years before he died, saying that we gotta view Mars. We have to understand we're planet. He found an observatory named for himself, and it is still active today, looking at Mars and well beyond. It's also the place that Pluto was discovered. But that's for another talk in a couple of weeks. And next. This is killer. To tread the soil of the asteroids, to lift by hand a rock from the moon, to observe Mars from a distance of several tens of kilometers, or land on the satellites, or even on its surface. What can be more fantastic? It's Konstantin Tsiolkovsky, a Russian rocket pioneer. There's a great photograph of this gentleman. I think it was in his late 50s or his 60s. And right next to him, listening to him like a schoolboy or girl, is Joseph Stalin, absolute dictator of the Russians, if you will. But he's listening to him, and he's fascinated. Originally, he was looking at rockets so they could be used for attacking the United States or whatever, but he caught the bug. And that's the best thing about it. Okay, next. And I'd like to thank my wife, Bonnie. Mary, of course, over here, Cliff Ashcraft, who got your photographs, Cliff, if you're there, have inspired me to continue with my photography. NASA, of course, European Space Agency, and all our observers here at AAI. I have to thank all of them. And I thank you, ladies and gentlemen, boys and girls, for being here, and I wish you luck in the future. Now, before we come up here, which will probably be like a small stampede. I brought in 2 samples from my meteorite collection. One is from Mars. We know that because we have robots up there that told the composition. And the other one from the moon. Of course, we had people walk up there. And their samples are very, very close to this. I have a magnifier so you can get really close and personal with it. Before we do that, though, are there any questions out there? I've dazzled everybody. Holy cow. Okay.
You said in the polar ice caps.
Yeah.
You said there's not, besides dry ice, there's some water.
That's right.
So could that be a potential place to set up a base
You're
to?
spot on. That's exactly right. We have water there. Even carbon dioxide, you can break it down or chemically change it into a fertilizer. So you have could make farms on the surface there. Pressurized, of course, if you want. But yeah, exactly right. Very good. Anyone else? Hand over on the side.
Al, you didn't mention the book and the film by Andy Weir, The Martian. How authentic do you think it is?
It's close. The rescue has got me a little, like, come on, this is pushing it. However, surviving on the surface of Mars like that, and having that technology around, I think that's pretty darn plausible. We'll see what happens. Hey, it's better than having a large meteorite crash into the Earth, and the end of it unscrews, and then these alien creatures come out, and it's bigger rays. Good book, good movie. The book is good, better than the movie. The War of the Worlds, 1953, cut my eye teeth out. It's fun. But, and yes, we survived. The Martians were wiped out by our 1900 bacteria. Anyone else?
Any questions from our online viewers?
Yes.
Yeah, I read.
Okay.
Can you hear me?
Yes.
Okay. I have a question for Al regarding how do we determine that a certain meteorite is actually originated from Mars?
Okay. For those that didn't hear it, how do you determine a meteorite found on the Earth actually came from Mars? The answer is very simple. We guessed about it until 1976 when we had the Viking 1 and 2 landers, and they could analyze the rocks, and then later spacecraft followed. And it matches very closely what we see in certain very rare meteorites. And it's very good. It's very cool to know that I've got a piece of Mars in my backyard, if you will. Any other questions?
Thanks, Al.
Cliff has his hand up. Cliff?
Yes. Al, I read recently that through reanalysis of the earthquake data from InSight, they found what happened to the oceans on Mars. It's below ground, but they can account for a couple of kilometers to fill up that southern abyssal plain or northern abyssal plain.
Fantastic. That means there's water there, and once you purify it, we just come running.
Went down the drain.
It's a little bit deeper than the deepest well that's been dug on the earth, though. So it's way down there.
Yeah, but give it to an engineer; they'll figure it out.
Yep.
Anyone else?
Any other questions?
All right then. Thank you for your
Okay.
attention. Thank you for coming tonight.
Thanks,
If
everyone
it's
online.
cleared out there, please use the scope. And before you go up, though, you want to take a look at the moon and Mars.
Everybody have a good evening.
How's it going, Steve?
Take care.
And on the derivatives, that was called fusion. Kind of ran out of meteorites where they go out so they investigate find them end up intercepting themselves. That way they can certify it's definitely from this kind of rock, whatever, and then they can check the price on the internet. So that's it.